Okay, to finish up 8.3, we introduced the log functions. We looked about how to rewrite them, some of the more common logs that you're going to see, as in the common log and the natural log. The second part of 8.3 is actually answering the key question: how do you find the inverse of a log function? And we found the inverses in chapter 6. The first step's the same. Okay? When you're finding the inverse of a log function, the first step is to switch x and y again. So we're doing that same work. F of x equals log base 8 of x. Now, this is actually going to be a lot of the solving that you're also going to have to do when we get into that in 8.5. So the first thing I'm going to do is our first step is switch x and y. Remember, f of x can just be written as y equals log base 8 of x. I'm going to switch my x and y. X equals log base 8 of y. And now, once all you have is a log function, there's nothing outside on either side to get rid of, you're not adding anything, what you're going to do is take that log function and write it as an exponent. So here we have log base 8 of y, so our base is 8, our exponent is x, equal to y. Since y is by itself, there's nothing else to do, and there's our inverse function. 8 to the x power equals f negative 1 of x. Okay. So one thing you're going to need to look for is if there's things to get away from the log function, but once everything's gone, rewrite it as an exponent and see if there's anything to move around with that y. So here we have f of x equals log base 7 of x plus 3. And I'm going to do the same thing. Switch my f of x to y and switch it. So I'm going to do all that in one step here. I'll make it x equals log base 7 y plus 3 in parentheses. Now, that y plus 3 is in parentheses, so we can't really do anything with it now. That's not considered anything we need to get rid of away from the log. It's part of the log since it's in those parentheses. So the next step is to write it as an exponent. Okay? Our base is 7, so we're going to have 7 to the x power equals y plus 3. And now, unlike this time, there's that plus 3 there. Over here, y was by itself, so we were done. Here, we still need to get rid of that 3. Subtract 3, and now just thinking about how this looks. 7 to the x power. Do you think you can combine that 7 and 3? No, they're not like terms. 7 to the x power minus 3 equals y. And let's just write it. 7 to the x power minus 3 equals f of negative 1 of x. All right. So there's 2 examples. Let's do a couple more. So here we have f of x equals log base 3 of x minus 4. So right away I'm just going to switch some things around. Bring my x over, switch that with the y. And now let's take a look at it. Now, the difference between this example and our last example is that that y plus 3 was in parentheses here. Over here, it's not in parentheses. It's y minus 4. Okay, so this time I am going to get rid of that 4 first. I'm going to add 4 to both sides. And now I have log by itself. So now is when I'm going to write this as an exponent. The 3 is the base still. Now that whole x plus 4, that whole thing is going to become the exponent. I strongly suggest writing it in parentheses just to show you know that whole x plus 4 is in the exponent. Equals y. Now if there's more things with the y, we would keep getting rid of it. Since y is by itself, we're done. 3x plus 4 equals f negative 1 of x. Okay, so there's those examples there. Okay. So you look at it, you need to get everything away from the log. Once everything's away, you can turn it into an exponent and then continue getting y by itself or isolating y. Okay. I want to do one more example, and let's do f of x equals natural log of 4x. So now we're dealing with natural log. I'm going to suggest when you look at this problem, as soon as we see the ln, let's rewrite that as log base e. That's how we look at things. We're going to put them in exponent form. So let's look at it as f of x equals log base e of 4x. So I just rewrote the natural log there. Let's take our x and y and switch them. X equals log base e of 4y. The 4y is in parentheses, so I'm not going to get rid of that 4 just yet. I'm going to write it as an exponent first. E to the x power equals 4x, or sorry, 4y. And now we can get rid of the 4 to get y by itself. Nothing to simplify over here. E to the x over 4, f negative 1 of x. Okay? So this example just showed you when you have the natural log, write it as log base e. Okay? When you're simplifying, think about what like terms are. When can you simplify a fraction? When can you add and subtract like terms? With having the variable in the exponent, things will look a little different. But remember, that is making that is a part of that term. Okay? And a lot of people see, just a separate side note here, when you start dividing afterwards, things kind of like this, you might get something as 15 to the x power over 3. People want to simplify that to 5 to the x power. 15 over 3 simplifies to 5. With that exponent though, you can't do that division. Okay? So if simplifying the fractions do get, I think, kind of a little easier. There's less you can do, but you just have to make sure you identify when you can and can't simplify those fractions. Okay? So that's the end of 8.3, finding the inverse.